Here we go on molarity. Okay, molarity. Um, Molarity is one of maybe, I don't know, 4 to 6 ways. I can think of at least four, maybe 5 ways of calculating what's called concentration. Now, anytime you talk about a concentration in solutions, okay, we're going to dissolve something, probably a solid, doesn't have to be, probably solid liquid. You can even use gases in most of the time water. Okay, when we talk about molarity, we will be talking about typically water. When we talk about aqueous solutions with a certain concentration or molarity, whenever we use the word aqueous and molarity, aqueous, it refers to water. Okay, so um, so molarity, what is molarity? Molarity is a way that we calculate how concentrated or dilute a solution is. And the solution is, again, dissolving any one thing into something else. Okay? So whenever we talk about concentration, the most common form is to talk about, the most common form of calculating concentration is with molarity. Okay? So what is molarity? It's, as you can see here, it's the moles of solute, and solute is the substance that is dissolved. So this is the substance that is the dissolved substance. Okay. For us in AP chemistry and honors chemistry or whatever chemistry you're referring to, this is probably going to be a solid. Probably. Doesn't have to be, but probably a solid. Okay. And then now we're going to divide that by total liters of solution. Okay. So that's the total liters of solution. Okay, so make sure you pay attention to that. So the units actually for molarity, molarity should be underlined because it's italicized. I won't always do that, but just so you know, um, it's moles per liter. Okay, you'll see me define that moles per liter sometimes and sometimes not. It just depends on how I want to use that. So keep that in mind as we move through here. Okay, so as we see a problem here, okay, which is more concentrated, a 1.00 times 10 to the negative 2 molar solution of sucrose, again, that's sugar, or a 1.00 times 10 to the negative 4 molar solution of sucrose. Very easy question here, but just don't get confused. When you take a look at these two numbers, don't forget that does not mean more. That actually means less, okay? So just be a little bit careful. The correct answer to this one is this one, okay, which is more concentrated. This is 0.01 moles per liter or molarity. This is 0.0001 moles per liter, okay, or molarity. Okay, so this is way less concentrated. There is not much stuff here. This is what, 100 times greater, okay, as far as concentration goes. Okay, so let's work through a couple problems just to see how molarity works. Okay, so as far as molarity goes, this is a problem. It says calculate the molarity of a solution made by dissolving 23 grams of sodium sulfate in enough water to form 125 milliliters of solution. Okay, so the first thing we should do is just make sure that we know what equation we're using. And we're probably going to use molarity. Of course, we will use molarity. That's moles of solute over liters of solution. It says calculate the molarity, so we'll be calculating this, and they should give us enough stuff to solve the problem, enough stuff to solve in the body of the problem. So I notice I have 23.4 grams of this substance called sodium sulfate, and I have 125 milliliters of total solution. All right, now I don't have any moles listed, so I'm going to have to deal with that later. My personal philosophy is go with what you know. Go with the path of least resistance, and that is this. I'm going to go with this. I know I have 125 milliliters of total solution. Well, don't forget, that 125 milliliters can go down here, but that's in liters, okay? So we do have to do a quick metric conversion from milliliters to liters, and that just involves moving the decimal place over 3 places to the left, okay, to go convert from milliliters to liters, okay? So that gives us that, but I still have this issue with moles. I don't have any moles listed, so we could do a mass to mole conversion. So let's do that real quick, okay? So let's do this. Let's take 23.4 grams of sodium sulfate, which is Na2SO4, okay? And we have to find the molar mass here, okay? So don't forget, if you have grams of Na2SO4, that's going to go on the bottom. And your moles of Na2SO4 will go on top, so we can end up with that. Now we just need a molar mass of Na2SO4, and I keep my molar masses pretty simple. So I'm just going to use whole numbers when I can. So the molar mass of sodium is 23. So 23 times 2 is, of course, 46. I'm going to add that to sulfur. And sulfur, I got to use 32.1 here because that's not so easy to use as a whole number. And then I got to add that to 4 oxygens. Okay, that's 16 times 4, which I believe is 64. And you end up with 142.1. Okay, 142.1. So we'll put that down here. That gives me enough sig figs. I have 3 sig figs. I have 4 sig figs. That's perfect. So I want to divide the two. So 23.4 divided by 142.1 gives me 0.0165. Okay, so that's, excuse me, I said 0.0. It's 0.165. Sorry about that. And that's moles of Na2SO4, our solute. So that goes there. Okay, let's plug that in. Let's go back to our blue pen. There we go. So we're in moles per liter. That's exactly what I want. Let's clean this up just a little bit here. So now all I have to do is divide. So 0.0165, or excuse me, 0.165 divided by 0.125, you end up with a molarity of 1.32. 1.32 is our answer. 1.32 molar, and you always reference the solute, Na2SO4. So you notice I did go back to the big M here. Okay, I didn't write moles per liter. If you did, you'd still be right, but that's a little bit more quicker way to do that. Okay, let's try another. Okay, so in this problem, it says find the mass, okay, of a solution that contains 250 milliliters of 0.1 molar NaCl. So again, if you come across a problem, it's a very random problem. I know they're asking for mass. They give me volume, and they give me a concentration in the form of molarity. So I can use the molarity equation to solve for moles. And once I solve for moles, you can convert to mass using a molar mass conversion. Okay, or molar mass has a conversion factor. So I'm just going to multiply by liters on both sides. You're going to end up with moles is equal to molarity times liters. Once I get my molarity, once I get my moles, I will convert that to mass. So that'll, I should put that there. It looks like a gas, but anyway, we'll convert to mass. Okay? So let's try this. We will use the equations I just listed. I'm just going to erase them so I have a little bit extra room. So moles is equal to molarity times liters, as I just worked out. Molarity is listed. That's beautiful. Now look at, I'm gonna write out moles per liter. Okay, I do that so I can get my units to cancel, and then I'm going to use 250 milliliters, but I'm not going to use 250 milliliters. I'm going to use 0.250 liters. I did a quick metric conversion in my head by moving the decimal place 3 places to the left. So 0.25 times 0.1. Again, if you can do some quick math, you're going to move the decimal point to the left, but it doesn't matter. Throw it in your calculator. You'll end up with 0.0250 moles of NaCl. Okay? Now, that's not quite our answer, though. That's only in moles. Okay? So now we have to convert to mass. Okay, it says find the mass. So always be careful and make sure you know where you're at in these problems. So 0.0250 moles of NaCl, again, using molar mass as a conversion factor. You're going to put 1 mole of NaCl on the bottom, and 1 mole of NaCl has a molar mass of 58.5. And now you're going to multiply these two numbers together, and you end up with 1.46 grams of NaCl, and you are done. Okay, so that's that problem. Let's try another. What are the molar concentrations of each of the ions present in an aqueous solution of calcium nitrate? Okay, this one's a little bit more involved. Okay, so what are the molar concentrations? This one's a little bit tougher. Okay, so if you ever want to pause a video and try to work it out on your own, that's fine, and then press play to kind of keep it moving. The only number they give us is 0.025 molar CaNO3 2. Okay, The first thing I would do is consider a dissociation reaction. CaNO3 is interesting because when it dissociates, it's a strong it's a strong electrolyte. You're going to get Ca2 plus aqueous plus 2 NO3 minus aqueous ions. So one of these becomes one of these, correct? So that's a quick 1-to-1 mole-to-mole ratio. But one of these becomes 2 of those. So we have to do some doubling here, okay? And we're going to show that with a mole ratio. Okay, so if we do the math very simply in our heads and we reason this out, we know that if this is a 1-to-1 relationship, and if I have 0.0250 or 25 molar or moles per liter, let's say, of this stuff, and I produce the same mole amount or molar amount, this will also be 0.0250 mole per liter. Okay? Now, what did I do to reason that through? I used a mole ratio. Let me show you what I mean. Okay? I have 0.0250 or 0.25 moles of calcium nitrate, and I use a mole ratio. 1 mole of calcium nitrate according to my balanced dissociation equation, that's the one I'm using right there, to 1 mole of calcium ions will give me the exact same amount. That's one answer. It says calculate the both ions present. Okay? Now, let's go one step further. We've got to find nitrate. I said it was a doubling effect. It is. Let's go back to calcium nitrate. Okay? If I have 0.025 moles per liter or molar CaNO3 and I set up a mole ratio now, it's 1 to 2. So if I have 1 mole of CaNO3 that becomes 2 moles of nitrate. So I'm going to double this. This will be double. This times 2. So 0.050 moles of NO3 is produced in this problem. Okay, so we double it. Be careful with those. Okay, moving forward. Hopefully I don't know if it, there we go. Okay, how many grams of Na2SO4 are required to make 350.350 liters of a 0.5 molar Na2SO4? I'm not going to do this one, but I'm going to show you how to do it. It says how many grams. The only way I can calculate grams using the molarity equation is to first solve for moles. Once I solve for moles, I can use the molar mass conversion factor to find mass. Okay? So I would simply go moles multiply, again, I'll just show you real quick, 0.500 moles per liter of Na2SO4 times 0.350 liters, you end up with a certain molar amount, a mole amount, I'll call it X, and then convert to mass. Okay, not too bad. The last thing I want to show you is the dilution equation. Okay, dilution equation is a real quick way to solve for concentration. Okay, so usually the problem will say it will be diluted, or you're going to take a more concentrated batch to a less concentrated batch. Be careful with how much you use this one. Sometimes it works very simply because the problem is set up that way, but then another time the problem is not set up that way, and then you end up using the wrong equation. So just be careful, but let me show you how to work this. It says what volume of 16 molar. Okay, so I have a volume, I have a concentration. It's used to prepare a, oh, here's another one, here's another volume. and here's another concentration, okay? Now notice these two seem to go together, and these two seem to go together. So let's just call these ones and these twos. It doesn't matter what you call them. You could have called these ones and these twos. It doesn't matter. We'll stick with our original designation, okay? Question says, what volume? So this is our X, okay? So let's do this. We're going to say M1 is 16 molar times V1, which is our X. I'll just write V1. I like to keep that in there pretty consistent. And then it says what's our equal to M2, which is in our V2, which is 1.5 liters. Okay. Multiply 1.5 times 0.1, which should be 0.15. And then, so this, let's do it this way. 0.150. Now that's in, well, I'm trying to avoid units, but that's fine. It's moles. And then you're going to go over here. And now you have 16 molar times your X. So you're just going to divide that by 16. 0.15 divided by 16 gives you an answer of 0.00937. Or, now that's liters, guys. Just be careful. Now, if you're confused about that, let's just look real quick here. It's moles per liter here. So whenever you divide, you're going to cross off your moles. So you'll end up with 0.00938 liters. You can keep that. That's weird. It's a little weird. I would convert that to milliliters. That's 9.38 milliliters. And you'll see why again. As the course progresses, why that's a good thing to do to convert to milliliters. How would you prepare this? I'm going to cover that in a next video when we actually talk about making molar solutions using a volumetric flask. But that's it. So if you have questions, let me know.